Dinosaurs might have been the most successful land animals of their time, and insects the most sociable, but there were plenty of other creatures around and about as well. At about the same time that dinosaurs came on the scene, another type of creature was living in the shadows. Mammals are descendants of creatures related to Dimetrodon, the one with the snail on its back, and Lystrosaurus, the one that survived the terrible Permian mass extinction. Mammals went a lot further than Dimetrodon in controlling their temperatures. The ability to keep your body warm when it's cold outside is called being warm-blooded. Because mammals were warm-blooded, they could hunt at night and sleep during the day, avoiding the worst predators. Most of them were also small. That made it much easier to hide away in the daytime under rocks or inside a tree. And to help stay warm, mammals grew fur. Actually, the reason we have hair goes all the way back to our rat-like mammal ancestors. They developed fur all over their bodies to keep themselves warm while hunting at night, so they could escape attack from the dinosaurs. How could they hunt in the dark? Most nocturnal animals have eyes that contain lots of light-sensitive cells called rods. These help animals like cats see when there's very little light. Some mammals have eyes that are great at detecting movement. They can see their prey darting around even in very low light. Mammals have also developed excellent hearing. This allowed them to detect the faintest rustle of a possible meal in leaves and grasses. Much later, a few mammals, such as bats, would develop this amazing hearing even more. They use a system called echolocation, allowing them to create a detailed mental picture of the world around them using sound. Another way mammals became pros at night hunting, was by growing the smell interpreting part of their brains. They used their noses to find the yummy food they crave. If you have a cat or a dog, you'll know exactly what I mean. Then disaster struck once again. Dinosaurs had dominated life on land for about 180 million years, but then they were utterly wiped out. Only the birds survived. Pterosaurs, the flying reptiles, also vanished. So did the marine reptiles, except for the turtles, which somehow survived. It was also the end of the road for the ammonites, those spiral-shaped creatures, relations of today's octopuses and squid. How could this happen? About 65 million years ago, a humongous asteroid hurtled towards Earth. As this dark chunk of deadly rock and ice made its final approach, planet Earth would have looked like a sparkling blue and green jewel in the black void of space. Down came the asteroid, possibly splitting up into several pieces before finally smashing into an unsuspecting world. Asteroids and meteors fall from the skies in constant rain, even today. But usually they break up and burn out as they cut through the Earth's thick, heavy atmosphere. You can sometimes see meteors yourself on a clear night. They are commonly called shooting stars. But this was no ordinary shooting star. This tiny thing was about 10 kilometers wide. That's the size of a large city. It hit the Earth with the force of 1,000 nuclear bombs, blasting a crater more than 160 kilometers wide. Everything in a 1,000-kilometer wide area was wiped off the map in seconds, leaving behind an enormous cloud of deathly hot, toxic gas. The noise and sight of the impact would have deafened and blinded countless living creatures. Many of those not killed by the blast would have been drowned by giant waves created by the impact. Earth was plunged into darkness by thick, heavy clouds of rock and dust, lasting for as long as a year. Plants all over the world died from the lack of sunlight and from a cooling climate. Even on the opposite side of the globe from the impact, animals died of starvation. Dinosaurs' times were over, just like that. Mammals, well adapted for living in the dark, were quick off the block once the dinosaurs were gone. Well, it seems quick when you're moving through time as fast as we are. Within 3 million years of the meteorite catastrophe, shrew shrew-sized mammals had evolved into creatures as large as dogs. Within 5 million years, mammals of all shapes and sizes roamed the land. This period of time, from 56 to 34 million years ago, is called Eocene. Eocene means new dawn in ancient Greek. Our 24-hour clock on Earth's history is shown between 11:42 and 11:49 p.m. It's now that the ancestors of modern mammals came onto the scene. There were carnivorous predators such as Andrewsorchus, which looked like a wolf but was 22 bigger than its modern cousin. Even more amazing was the thunder beast Megacerops. This was one huge plant eater that looked like a rhinoceros, but was the size of a modern elephant. But not all Eocene mammals were gigantic. The ancestors of today's horses appeared then too. One was Hyracotherium, which was only as big as a middle-sized dog. One group of Eocene mammals is of very special interest. In fact, creatures from this group, primates, will become the main focus on the next part of our story. Modern primates include monkeys and apes, lemurs and aye-ayes. But the first primates looked more like squirrels. Early primate fossils have been found all over the world. Monkeys emerged around 30 million years ago in Africa or Asia. Soon after, one or more groups of these monkeys somehow crossed the Atlantic. It's a bit of a mystery how they did it. Some experts think they found themselves bobbing on a raft in the middle of the ocean, eventually to be washed ashore on the coast of what's now Brazil. We call the descendants of monkeys that made this journey the New World monkeys. And the ones which stayed behind in Africa and Asia are called Old World monkeys. These two main groups of monkeys still exist today. The New World monkeys of South America have flat noses and use their tails to help them swing and balance in the trees. Some species can happily hang from a branch by their tail alone. It's as if they have an extra hand. Apes evolved from monkeys. Paleontologists have found fossils of early apes that date to 14 million years ago in Europe, Asia, and Africa. So it's hard to figure out where they first appeared. Over time, these early apes evolved into today's great apes: orangutans, gorillas, chimpanzees, bonobos, and humans. Yes, humans are apes. Biologists have discovered that the DNA in you and me is 98% the same as the DNA of other great apes. And they figured out that humans and chimpanzees have a common ancestor that probably lived sometime between 4 and 7 million years ago. That's not long ago when you look at our clock. After all, it's only about 2 minutes before midnight.
Hands free!
Chapter 4. Hands free. A lot of people are talking about climate change these days. It's a big deal because the world is warming up. It's a big deal because the world is warming up and the ice caps are melting, which is especially bad news if you happen to be a polar bear or a coral reef. But it's fairly bad news for humans too. The less ice at the poles, the more water in the seas, and that makes the water rise higher up on land. One day there could be no ice left at all, and if that happens, the seas would be 66 meters high. 66 meters higher than they are today. That means that if 42 football players stood on one another's shoulders on a present-day beach, even the top one would need to be wearing scuba gear. Seas that high would swamp most of the world's coastal communities. Millions of people would have to leave their homes, and that's why people are worried. But for the Earth, being ice-free is pretty normal. For most of Earth's history, there have been no ice caps at all, and the seas have been as high as that 60-meter level. Every so often, things would change, and the world would get colder, and the seas lower. Remember Snowballer? They would get warmer again, and then colder, and then warmer. One of the times things began to change was about 5 million years ago. At the time, the world only had one big ice cap on Antarctica. Then something pretty major happened. The tectonic plate that carries South America met the tectonic plate that carries North America. The two continents ended up attached by a thin piece of land that today is part of the country Panama. This new land connection forced Atlantic sea currents to flow northwards as a result, a new climate system spluttered into life. It pumped warm air north and heated up winters in the northeast, northwest Europe by at least 10 degrees Celsius. The warmer water in the North Atlantic started to evaporate more quickly. Water vapor traveling north collided with cold air in the Arctic, where there was probably already a little ice. Over time, the snow settled in layers and formed thick packs of snow. And so by about 25 million years ago, the Earth was wearing a second big ice cap, this time in the Arctic. How do we push pause? With huge ice sheets now on both poles, the Earth plunged into a super deep freeze. Colossal ice sheets called glaciers swept southwards from the North Pole. Sea levels plummeted because so much water was trapped as ice. The Earth was in the grips of a full-blown ice age. And here's the amazing thing. It still is. This whole time since the glaciers started forming almost 3 million years ago, the Earth has been in a cool spell. It hasn't exactly stayed the same temperature all that time, of course. It's got warmer and colder and warmer again. Glaciers have crept onto the continents, then pulled back again, then crept up again. But all that time, the Earth has had two large ice caps. Just in case you were wondering, we're now in a warm time in the Ice Age, what's known as the interglacial period, and it's getting warmer fast. And you know what else happened over that time? Humans, that's what. Human ancestors were already around a million years before the deep freeze started. But we modern humans evolved during an ice age, and that has made all the difference to our story. Lucy was an ape who lived in what is now Ethiopia in Africa about 3.2 million years ago. She was discovered in 1974 by a team of scientists headed by American Donald Johanson. They gave her a woman's name because her skeleton was small, which they guessed meant she was female. They called her Lucy because when they were celebrating the find, the team was listening to the Beatles song Lucy in the Sky with Diamonds. Her species name is Australopithecus afarensis. Lucy was about 1.1 meters tall and weighed about 29 kilograms. When her discovery was announced to the world, Lucy caused a sensation. Why? Because experts could tell from the shape of her bones that she definitely walked on 2 feet, and humans are the only modern apes that do that consistently. No one is quite sure why it was that made apes like Lucy stand upright, but it turned out to be a great advantage. With their hands free, they could carry food more easily, helping them to survive even when times got tough. Being hands-free means you can carry tools too, and think how much easier it would be to hunt with a spear or to carry nuts wrapped in animal skin. Since Lucy's discovery, bones and teeth of lots of other similar creatures have been found. But was Lucy human? If being human means belonging to a group of apes that walks on 2 feet, then Lucy counts. But if it's about having big brains, then we must wait another million years or so for our genus, Homo. The first species experts feel safe calling human was Homo habilis. Its brain was 500 to 800 cubic meters, nearly twice the size of Lucy's, although still half the size of our own brains. And this species was very good at making tools. That's why Homo habilis marks the beginning of what is known as the Old Stone Age. It's about 2.4 million years ago and just 45 seconds to midnight on our 24-hour clock of Earth history. The age of humans has finally